Hello and welcome to my live stream, Learn Python from Scratch with futurecoder. I'm going to have a sip of tea and then let's get right into it. First, a few words on why I'm here. I've been studying OSSU, the Open Source Software University's computer science curriculum, and someone who was once active in that Discord had contributed some discussion to OSSU, but also listed themselves as a contributor to futurecoder. And I thought that futurecoder looked interesting and would be worth exploring on my live stream. So here I am about to dive into futurecoder. Yes, here we go. Where's my mouse? There it is. Start learning. Okay, introducing the shell. I'm going to do two things here. I'm going to work through this as though I'm learning this for the first time, but I'm also going to add commentary where things might potentially be confusing or where I have some perspective on how I've used something from this course in the real world. So, without further ado, let's get into it. Introducing the shell. On the right is the shell. This is a place for running small bits of Python code. Just type in some code, press enter, and it'll run. Try it now. Click anywhere on the shell, the black area. Type 1 plus 2. Press enter key on your keyboard. So look at that. From the start, we're doing something interactive. That looks like a good way to be learning this. So it says, great. Python evaluated 1 plus 2 and got the result 3, so the shell displays that. The shell is probably your most important tool for learning Python, and you should spend lots of time experimenting and exploring it. Be curious. Constantly ask yourself, what would happen if I ran X? And then immediately answer that question by running it. Never be too scared to try something out. If you get something wrong, nothing bad will happen. Try doing some more calculations now. You can multiply numbers with star, divide with slash, and subtract with dash. You can also use parentheses, i.e. left paren and right paren. I'm curious what will happen if I type 1 plus. Syntax error, invalid syntax at line 1. And futurecoder has added some additional context, so I'll read that. A syntax error occurs when Python cannot understand your code. I am guessing that you wrote plus by mistake. Removing it and writing 1 seems to fix the error. Okay, so let's try that. Just enter 1, and that works. Or we could go back to 1 plus 2, and of course that works. What if I just enter plus? It says syntax error, invalid syntax at line 1. And futurecoder adds, a syntax error occurs when Python cannot understand your code. We've seen that before, but I'm repeating it. It says, currently I cannot guess the likely cause of your error. Well, that's because what I did makes no sense. Try to examine closely the line indicated as well as the line immediately above to see if you can identify the misspelled word or missing symbols like paren, blah, blah, blah. Click to expand. Well, we don't need to go into that extra detail there. Let's just go back to friendly, familiar 1 plus 2. Or I can try like really big numbers. Still seems to work. I'm not going to verify that that result is correct. I'll just trust it. Okay. Let's do some more calculations. We can do multiply. 3 times 4. Sure. 3 divided by 4. Sure. Notice we introduced a decimal point. That's something that may come up in more detail later in this course. and 1 4 plus 3 times 2. Sure. Let's do, I'm ready to continue. Are you ready to continue? Let's continue. Navigating shell history. Here's a tip. Often you will want to rerun a previously entered bit of code or a slightly modified version of it. You can copy and paste, but that's tedious and gets in the way of experimenting. A better method is to press the up arrow key on your keyboard. This will insert the previous line of code in the shell. Keep pressing it to go back further in history, and if you go too far, press the down arrow to go the other way. Try using it now. So we go up, there's that one. We go up, and notice I click up, it goes to 4 plus, etc. I click up again, and again it goes to 4 plus, etc. But then it goes to 3/4, and so on, 3 times 4. I can hit enter. I can go too far back in time and then come back to 3 divided by 4. I think I get it. I'll move on. Introducing strings. Python lets you do much more than calculate. In fact, we're going to not touch numbers or maths for a while. Instead, we're going to look at strings. Strings are essentially snippets of text. For example, enter the following into the shell, quotes included. So we have quote, Hello, quote, and it says enter the following into the shell, so I will hit enter. The shell simply gives us back the same thing because there's nothing further to calculate. Hello is simply equal to hello. I wonder if I could make the text bigger. Let's try it. That still looks okay. Let's go a little bigger. That still looks okay. I think that's better. Sorry if the text was too small before. The quotes are not part of the string. They are, okay, sorry, where was I? Simply equal to hello, yes. A string is a sequence of characters. A character is a single symbol such as a letter, number, punctuation, space, etc. In this case, the string contains the 5 characters HELLO. The quotes are not part of the string. They are there to tell both humans and computers that this is a string consisting of whatever characters are between the quotes. It's important to note that they said something to tell both humans and computers, because code is written for both humans and for computers. Adding strings. Strings can be added together using plus, although this means something very different from adding numbers. For example, try, quote, hello, plus, quote, world. Hit enter. Now, let's go on with what they say, and then I have a point I want to make. It says, you can see that plus combines 2 strings together end to end. Technically, this is called concatenation. Here's an exercise. Change the previous code slightly so that the result is the string hello space world, i.e. with a space between the words. By the way, if you get stuck, you can click the light bulb icon in the bottom right for a hint. What I want to talk about is the spaces here. Why did I put a space there, and does it matter? Well, the reason why I put a space there is that it looks nice for humans. But to answer the question of whether it matters, let's try HELLO plus with no space world. And it's going to get mad at me because I'm not doing what it told me to with hello space world. But that's okay. Notice that hello space, I won't read it all out, but notice that here we have spaces, here we have no spaces, but the results are identical. Apparently Python doesn't care whether you put a space between a string in quotes and a plus operator. That's interesting. Does it care if we put a space within the quotes? Yes, it does. And let's show how that is. This time I put the space inside of my 2 quotes. You can see here there's quotes, and the space is inside the quotes. And now I have to decide whether I'll include spaces outside of the quote strings. When I say outside, again, this is inside. It's one quotation mark to enter the string and one quotation mark to exit the string. I will write a space here because I think it looks nicer. I'll add a plus and another space and then type world. Notice that I only put the space after world because they asked for a single space. And if I typed a space here, we would end up with two spaces, which isn't quite what they asked for. It says, well done. Any of the following are valid solutions. And just for emphasis, let's type those solutions in. Quote, HELLO space quote space plus space quote WORLD quote. Let's see that that works. And let's also demonstrate that it works without spaces between the strings and the plus operator. Quote, hello space plus quote world quote. Same result. Now we can try HELLO plus world. Oops, I forgot the space. Sure enough, that one works. And we can try quote HELLO quote plus quote space quote plus quote world quote. Now something interesting happened here. Notice that before we were dealing with two strings and adding them together with the plus operator. But apparently we can also deal with apparently we can also deal with three strings, having them being added together with the plus operator, with two plus operators. Sorry, I'm having trouble saying this. Three strings, 1, 2, 3, and two operators. Okay, I think I've made my point. Let's move forward before someone gets bored. Introducing variables. To make interesting programs, we can't always manipulate the same values. We need a way to refer to values that are unknown ahead of time and can change. Values that can vary. These are called variables. Run this code. WORD equals quote HELLO quote. Now the first thing to notice is it kind of appears that nothing happened. Well, let's read what they say about what happened. This creates a variable with the name word that refers to the string value hello. Now see what happens when you run word in the shell by itself. WORD. Enter. And look at the output. It says hello. Good. For comparison, run word in the shell by itself with the quotes. So quote WORD. Enter. What do you think the result will be? The choices are WORD, quote WORD quote, hello, quote HELLO quote, or error. You might be tempted to say hello or quote hello, but I'm going to choose the correct answer, which is to display the string. Wait, how do strings get displayed? Strings get displayed with their quotation marks. I almost tripped myself up on that one. So it's just going to send the value back, including the quotation marks, to show us that we're dealing with a string. It says correct. I kind of wish I had said the incorrect answers just to see what the pedagogy would have been for that. Okay. As you can see, the quotes make all the difference. Quote word quote is literally just word. Hence, it's technically called a string literal. When they say, it uses the word literally because that's literally what you're talking about. On the other hand, word is a variable whose value might be anything. Similarly, quote sunshine quote is quote sunshine quote, but what's sunshine without quotes? This would be a great time to experiment and see what happens. Remember that we're not going to break the computer by doing something that doesn't make sense. So if I type sunshine and hit enter, oh, interesting. It gives me an opportunity to take a guess. Well, let's think about patterns here. When I type quote word, it gives me back quote word. So when I type sunshine, maybe it would just give me back sunshine. Let's click that and submit. It says, oops, that's not right. You can try one more time. Oh, we only get one more try. I guess I'd better get it right this time. I know that the correct answer here is error, so I'm going to select error and submit. And now we get to see the actual result. Name error. So not only an error, but a name error. And it says name sunshine is not defined. It says some more about that here, but I'll skip away from that for now and say the answer is that sunshine looks like a variable. So Python tries to look up its value, but since we never defined a variable with that name, we get an error. Now let's read more about the name error. It says, a name error exception indicates that a variable or function name is not known to Python. Most often this is because there is a spelling mistake. However, sometimes it is because the name is used before being defined or given a value. This I think is too much detail for us to be very interested in right now, so let's just click the next button. Using variables and print. Previously, we made a variable word with the value quote hello with this code. Word equals quote hello. Now make a variable called your name whose value is another string. And there's a note here saying the character underscore in your name is called an underscore. Use it to separate words when you want a variable name containing multiple words. You can type it on most keyboards by pressing shift and hyphen dash minus this character. So now make a variable called your name. So I'm going to type YOUR shift dash for the underscore NAME, and I'm just going to say Eric because that is my name. Your noom. Spelling mistake there. Your name equal Eric. That's better. Okay, it says you can use variables in calculations just like you would use literals. For example, try hello, quote hello, plus your name. Quote HELLO space quote plus YOUR space NAME. Spelling it correctly this time. What do we think the result of this will be? I'll give you a moment to think about it and then hit enter. The result says hello Eric, and that makes sense, right? Because the value of your name is quote Eric, and when we add that to hello space, we get hello Eric. It now says, or you can just add variables together. Try word plus your name. What's this one going to result in? Maybe it'll be exactly the same as what we saw here. Actually, that doesn't look so nice, and they say so up there. Oops, that doesn't look nice. Can you modify the code above so that there's a space between the word and your name? Let's make that modification. I remember if I go clicking up in my history, I saw something kind of similar to this, where we did hello plus space plus world. Let's use that. Clicking the down arrow to return to a blank cursor. Word plus quote space plus your name. Enter. Hello, Eric. That looks a little better. However, I'll come to what they're saying later. What if we don't like that Eric is lowercase? Can we make a new definition statement to change the value in your name? Let's find out. Let's say your name equals quote capital ERIK. Again, when we store a value to a variable, there's no output, so it looks like nothing happened. However, if I click up and up, And now we look at word plus space plus your name. What will this result in? It says hello, quote hello space Eric with a capital E. So yes, apparently we can change the value inside of a variable. In other words, it varies, so it's a variable. Going back to what they asked, it says perfect. Can you modify the code above so there's a space between your word and your name? Perfect. Okay. Variables can also change their values over time. Oh, wow. It was sitting right there saying the answer to the question that I asked. That's kind of silly. Right now, word has the value hello. You can change its value in the same way that you set it the first time. Run this. Word equals, quote, Godbye, quote. Now observe the effect of this change by running word plus your name again. Remember that I can click up in the history, word plus space plus your name, and now it says, goodbye, Eric. Now it says, those quotes around strings are getting annoying. Try running this. print, quote, wrd plus space plus your name, not quote, and parenthesis, enter. It says goodbye Eric, but it doesn't show us the quotes. That's interesting. Hooray, no more quotes. We'll break down what's happening in this code later. For now, just know that print something displays something in the shell. In particular, it displays the actual content of strings that we usually care about, instead of a representation of strings that's suitable for code which has things like quotes. The word print here has nothing to do with putting ink on paper. But it kind of looks like putting ink on paper. So it has a little bit to do with it, at least, I think. Anyway, moving on. Writing programs. It's time to stop doing everything in the shell. In the top right, you can see the editor. That's up here. This is a place where you can write and run longer programs. The shell is great, and you should keep using it to explore, but the editor is where real programs live. Type the program below into the editor, then click the Run button. Okay, word equal, quote, hello, end quote. Name equals, quote, wrld, end quote. Print word plus, quote, space plus, quote, plus name. And look at the pretty colors. We'll talk about what those colors mean later. Word equal, quote, goodbye. Print word plus, quote, space, quote, plus name. And now let's click the Run button. It says hello world and goodbye world. So apparently everything we typed here, when we click the Run button, the output comes over here. It says, congratulations, you have run your first actual program. Go me. Take some time to understand this program. Python runs each line one at a time from top to bottom. You should try simulating this process in your head. Think about what each line does. I'll keep reading before I do that. See how the value of word has changed and what effect this has had. Note that when print is used multiple times, each thing, hello world and goodbye world in this case, is printed on its own line. Okay, so I read hello world. When Python executes this, I picture in my head a little thought bubble with a label that says word and the contents that say hello. Similarly, I have a thought bubble for name with the contents world. Then when it says print word plus space plus name, I imagine Python going to that thought bubble and pulling it and looking for the thought bubble named word and pulling out the value string world. Then from name, I'm getting twisted around in my thinking here. Word corresponds to hello. Name corresponds to world. And print apparently sends an output to the shell. Here we have hello world. Now we change the value of goodbye, so I imagine my thought bubble that was labeled word, and I erase what was previously there and write in goodbye, so that when we print hello plus space plus name, we get print word plus space plus name, we get goodbye world. That was a lot of talking, so let's move on with the course. Some things to note about programs in the editor. The program runs in the shell, meaning that the variables defined in the program now exist in the shell with the last values they had in the program. That's interesting. This lets you explore in the shell after the program completes. For example, name now has the value world in the shell. Let's test that. Name, enter, world. Then it says, programs run in isolation. They don't depend on any previously defined variables. The shell is reset and all previously variables are cleared. So even though word currently exists in the shell, if you delete the first line of the program and run it again, you'll get an error about word being undefined. Let's test that. Delete the first line and run. Did you mean ORD? No, I did not. It's a error traceback. Print word plus space plus name, name colon world. Oh, cool. It gives us the value within name. It says name error, word name is not defined. In other words, Python doesn't know anything about a variable named word. I want to select that. Okay. Let's try something interesting, though. What if I type word equals hello in the shell and click enter, and now try to run this? It's still the same error. So apparently, although definitions from the editor find their way into the shell, the reverse is not the case. To emphasize that again, if I say word equals hello, and I run this works, and if I ask Python what is the value of word, it shows me goodbye. But if I say in the shell that other word equals hi, and then try to add a line to this program that says print other word, I'm going to get a name error saying that other word is not defined, even though I tried to define it in the shell. Error traceback, print other word. Other word is not defined. Okay. Let's go back to this. Word number 3. If you enter code in the shell and it has a value, that value will automatically be displayed. That doesn't happen for programs in the editor. You have to print values. If you remove print from the program, changing the 2 lines to just word plus name, nothing will be displayed. It says, I recommend that you check all of these things for yourself. Let's check that by removing the prints from here and just typing word plus name. You might expect that the program, when it runs, would return the value of word plus name, since that's what happened in the shell. Let's show that happening just to review. Word plus space plus name, goodbye world. But if we run this program, there's simply no output. Interesting. The second one says, let's review the second one and test it. Programs run in isolation. They don't depend on any previously defined variables. The shell is reset and all previous variables are cleared. So even though word currently exists in the shell, if you delete the first line of the program and run it again, you'll get an error about word being undefined. Yeah, I did demonstrate that. The program runs in the shell, meaning that the variables defined in the program now exist in the shell. Yeah, we showed that. For example, name has the value world. Okay, we've shown all of those things. Let's move on. Storing calculations in variables. Often you will use variables to store the results of calculations. This will help to build more complex programs. For example, try this program. Let's select all and delete. Word equals quote hello end quote. Name equals quote WRLD. Sentence equals word plus space plus name. And then we print sentence. Excuse me. Let's run that. What do you think the result will be? What are the options? Sentence, word plus name, word plus space plus name, hello plus space plus world, quote hello plus world, hello world, or quote hello world. So let's think this through. Word is quote hello. So if I go down here and start, oh, it doesn't let me type things. Okay, word is quote hello. So imagine I erased word and put quote hello in its place. Imagine I erased name and put quote world in its place. If we put all that together, we get quote hello space world, and that gets stored in sentence. Now, if we were in the shell and we typed sentence, we would expect to see something like this: hello space world with no, excuse me. If I was in the shell and I typed sentence and hit enter, we would see quote hello world quote. It would be displaying the representation of the string as it would appear in code. But when we use a print function, the print function, we only display the content and we strip away the quotes. So the correct answer here is hello space world with no quotes. Correct. Very good. It says now sentence has the value quote hello space world quote, which can be used multiple times. Note that it will continue to have this value until it is directly reassigned, example with another statement like sentence equals something. For example, add these two lines to the end of the program. Oh, this is going to be interesting. Word equals quote g goodbye print sentence. Let's not run this. Let's think about this. If sentence is word plus name, then here sentence must be hello world. But now, if word is goodbye, what will sentence be? This is a little bit controversial because if you look up sentence, it says it's word plus name. And down here, we know that word is goodbye. So you might expect this to print goodbye world. In fact, I'm hoping it's going to allow me to guess that in the output here. So let's run this. What do you think the result will be? So I'm going to incorrectly say hello world, goodbye world. Oops, that's not right. You can try one more time. I'm going to guess correctly now that it is hello world, hello world. Let's check that that's right. Correct. And it says, unlike a spreadsheet where formulas update automatically, a variable like sentence doesn't remember how it was calculated and won't change if the underlying values of word or name are changed. So to create a mental picture, sentence equals the result of word plus name. So sentence is hello space world. Now we change the value of word so it says goodbye. But sentence remembers its own value. It doesn't remember how it got there. It just remembers what it is. So there's why we have hello world, hello world. To emphasize this a little more, if we go back and we now say, sentence equals word plus quote plus name, now it'll be hello world, goodbye world. We have to redo the calculation if we want it to take effect. If we don't redo the calculation, the value of sentence remains the same. Next. It says, good news, you've made it past the boring basics. We can start to write some interesting programs and have a bit of fun. I wonder why they don't have an indentation there. One of the most powerful concepts in programming is the loop, which lets you repeat the same code over and over. Python has two kinds of loops, for loops and while loops. Here is an example of a for loop. Try running this program. I'm going to say name equals quote WRLD. Oh, for character in name. Of course, it doesn't need to be indented before the for. I was just thrown off by the way that they had it on one line. I'll explain later what I was talking about here, but let's just bravely move on. Print character. So let's think about what this might be doing. Character in name. Name is world, and since we named this character, it would be intuitive to think that we'll get the character W, then the character O, and so on. Let's also remember that when we printed before, each new print function call gave its output on a new line. So we probably expect this to say W, then a new line, then O, then a new line, then R, and so on. Let's try it. Sure enough. WORLD. You can read the code almost like normal English. For each character in the string name, print that character. Each character is just a normal string. Character is a normal variable that is given a new value before the code after the colon runs. So the code above is equivalent to name equals world, character equals W, print character. Character equals O, print character. And so on with R, with L, and with D. It says, note that we could use a different variable name. Character just makes it clearer. Let's prove to ourselves that we could use a different variable name. Let's use thingy, because I like thingies. For thingy in name, print thingy, and let's see that this gives the same output. Yeah, it went so fast it's almost like it didn't happen. Name equals foo, just to convince ourselves that something actually happened. World, okay. A for loop generally follows this structure. For variable in collection, colon, code to repeat. The for, in, and colon are all essential. Let's prove that by taking away the colon and running this code and seeing what happens. It says, oops, for thingy in name, print thingy. Syntax error, invalid syntax at line 2. It says, currently I cannot guess the likely cause of this error. Again, I did something ridiculous, like leaving out an essential part of a for loop, and futurecoder didn't know what to think about it. Okay, let's go on to next. Indentation. This example loop for character in name, colon, print character works. We've seen that it works. Let's see that again. WORLD. It works, but actually it would usually and should be written like this. For character in name, print character. Specifically, the code to be repeated, known as the body, starts on a new line after the colon, and it must be indented, i.e. have some spaces before it. The code below, without the indentation, is invalid. Run it yourself to see. For character in name, they didn't define name, but let's leave name defined, because otherwise we'll have a new problem. For character in name, colon, oh, look at that. When I hit enter, it automatically indents it for me, because it thinks it knows what I want. Print character. Let's try that code. Print character. Indentation error. Expected an indentation block after statement on line at line 3. After statement on line, is that line 2 at line 3? Okay, it's for some reason not showing me everything. That's unfortunate. Okay. Should be written like that. Try it this way. The spaces are required to tell Python which lines of code belong to the body of the loop. This is critical when the loop contains several lines, which it often will. For example, run this code. Name equals, quote, WRLD for space character in name. And since it indented it automatically for me, I'll just go with that. I'm a little curious whether it was tabs or spaces, but let's not open up that can of worms right now. Print, quote, print paren character, and print paren, quote, dash, 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 quote, close paren. Let's run this. Now we have W and the dashes and O and so on throughout the word. Let's see, there are two indented lines, so they're both part of the body. So the dash, dash, dash gets printed after each character. Now try running the same code without the indentation in the last line. What do we think that will look like? Let's find out. So notice that we have world with each character on a new line, and then we have the three dashes. So only the indented part got repeated. It says, since print dash 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 is not indented, it's not part of the loop body. This means it runs only once after the whole loop has finished running. Both programs are valid, they just do different things. The program below is invalid. Both lines in the loop are indented, but by different amounts. The first line starts with 4 spaces, the second line starts with 2. Try running it. So let's make sure that this is 1, 2, 3, 4. That's weird that it jumps across the 4 spaces for me. But anyway, 1, 2. Let's watch this fail hilariously. It says, indentation error. On indent does not match any outer indentation level, I think. Indentation level at line 5, yeah. In other words, we indented to 4 spaces, and Python, when we unindented, expected us to go back to 0 spaces of indent, but we gave it 2 spaces of indent, which Python hasn't seen before and doesn't know what to do with. It says, when you indent, you should always indent by 4 spaces. Any consistent indentation is actually acceptable, but 4 spaces is a convention that almost everyone follows. Do you want to be among the almost everyone, or do you want to be special? No, you don't want to be special in this case. You want to be like everyone else in this case. Note that the editor generally makes this easy for you. For example, if you press the Tab key on your keyboard in the editor, it will insert 4 spaces for you. So delete Tab, and it kind of looks like it's a tab character because of the way that my cursor jumps from the beginning to the end. But if I highlight it, you can see it's 1, 2, 3, 4 spaces. Just for interest, let's prove to ourselves that we can do this with 1, 2, 3 spaces instead of 4. Now, this looks mighty strange to me, but it should run correctly no matter what. I mean, it should run correctly anyway. And yes, we have W dashes, O dashes, and so on. Okay, let's move on. I've been going about 50 minutes since the stream started, which means I've been going about 40 minutes since I started talking. Or was it 45 minutes? I don't know, I've lost track. Pretty soon I'll take a break, but let's continue bravely for now. Basic for loop exercises. Time for some exercises. Modify this program. Name equals quote world. For character and name, print character, print quote dash dash dash. To instead output dash 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 W, dash 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 O, dash 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 R, dash dash L, dash dash world D. Okay, how can we change this? The first obvious thing to try is to put the first print statement before the second print statement. However, there's a problem with this. Can you see it? Let me show you. It says world, it says the 3 dashes, then the W. So that's close to what we wanted, except it's on a new line. Remember that each new print function ends with a new line so that the next print function can print on a new line. I think the most straightforward way to solve this is to use string concatenation, which we learned earlier. We take the quote dash 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 quote and add that to character, and that is what will be printed. So now it looks good. It says, splendid. Now write a program which prints name once for each character in name. For example, for name Amy, it should output Amy, Amy, Amy. For name world, it should output world, 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 world. It says, by the way, you can set name to anything in the first line, only the rest of the program after that will be checked. Let's set name to Amy just to fit with the example. And now, if we ran this code, we would get dash 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 a dash 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 m dash 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 y. But we want Amy 3 times. So the question becomes, can we access the variable name within the loop body? The answer is yes, we can. Let's show that. It goes 3 times Amy, Amy, Amy. Let's also demonstrate that it works with world, because it wouldn't be much good if it only worked with Amy. Yes, we get world 5 times. And what's another word? What's a 4-letter word? I can't think of one right now. I'll just keep going. Good. Good is a 4-letter word. For character in name, print name. This should print good 4 times. Yes, it did. Okay. We're making really good progress. You're solving problems and writing new code. Let's keep making things more interesting. That sounds good. Building up strings. Before we look at some more loops, we need to quickly learn another concept. Look at this program. Hello equals quote hello, print hello. Now, hello equals hello plus exclamation point. It asks, what do you think the line hello equals hello plus exclamation point does? Run the program to find out. Okay, let's hello equals quote hello end quote, print hello, hello equals hello plus exclamation point, print hello. Let's just find out what it does. I'm impatient to find out what it does. What do you think it'll do? Oh, it's going to make me think. Darn. So let's think this through. Hello is hello. So when we print hello, we'll get hello printed out. Then hello equals hello plus exclamation point. What is the value of variable hello? It's the string hello. What's the result of adding string hello to exclamation point? It's a string that looks like this. What are the other choices? Okay. So that discussion brings us to our answer, hello, and then hello exclamation point. Submit. Correct. What now? Okay. So it says, Python doesn't care that hello is on both the left and the right side of the equal sign. It just does what it would always do if the variables were different. It calculates hello plus exclamation point, which at the time is quote hello quote plus quote exclamation point, which is quote hello exclamation point. And that becomes the new value of hello. If it helps, you can think of that line as split into 2 steps. Temp equals hello plus exclamation point, and then hello equals temp. I don't know if it makes it more intuitive when we add another variable, but that is true, that it is doing something similar to that. I mean, it's doing exactly that. Well, something similar to that. I think I need a break soon. Or temp equal hello, and hello equal temp plus exclamation point. This is very useful in a loop. Let's actually try both of these and show that they work. So temp equals hello plus exclamation point. And now hello equals temp. But we need to remember hello equals quote hello. Then we can print the new hello. Let's run this. Yes, it works. And now let's do the other way, where we have the temporary variable equals hello, and now hello equals temp plus exclamation point. Let's try that one. Still gives the same result. And I want to show another way of doing this. Let's say this hello started as quote hello, and let's imagine that we had a new variable that we called new hello equals hello plus exclamation point. Let's print new hello. Still brings us to there. So this code does the same thing as this code. The difference is we lose this original HELLO. If we did something like new hello equals hello plus exclamation point, then we could print new hello, and we could also print the old hello. What would that output? Well, we have hello exclamation point, and then we have just hello. Okay, I think I've made enough of a point of that. This is very useful in a loop. Try out this program. Okay. Name equals quote WRLD, line equals dash, and for char, look, we've used a different name than character. Like we said before, we can use any name for the first part of the thing within the for loop. For char in name, and it indented for us, so I don't have to type any spaces. That's nice. We have line equals line plus char. And let's print line. So let's stop and think what this is going to do. We have world. We have character. We have line. Line starts as a dash. But then we take line plus the character and we store it back into line. And we print line with its new value. So at the first one, it's going to be dash W. But what about the second time we execute this code? We're going to come back up to here, and it's like we wrote the whole code all over again, but it's going to remember that new value of line. So to back up, for char in name, the first character is W, so line equals dash plus W. Print line dash plus W, dash W. For the next char, we have O, so the plus char here is going to be plus O, but line is going to remember that it had that W, so it'll be dash WO, and so on. Okay, let's look at this one. Dash W, that one doesn't make sense, because line and char are going to get added together. So we need something that starts with dash W, and dash W is on the same line. That's a good start, but what about this next one? Dash O. It'd be tempting to think that line has the value of dash, and so we get dash O, but that's actually not correct. Dash world is not correct. And why is that not correct? Well, because there are 1, 2, 3, 4, 5 characters in world, which means that this body is going to run 5 times. And because there's a print statement here, and print statements always give you a new line, we need an output with 5 lines. So that one only is 1 line, it can't be right. This one is only 1 line, it can't be right. This one looks pretty good. It has W and then WO, which is what I talked about before, and notice that it follows a similar pattern. Whereas what are we saying here? Oh, it's just that, but backwards. That's interesting. And world, well, it's not going to print name 5 times. If we wanted this output, we would have to just, for char in name, print name. So that one's wrong. And this one is more like print line, then follow it with name. Now print line. Now concatenate line twice and follow it with name. That's not what we see in this code. So again, the answer is dash W, dash WO, dash WOR. Correct. Okay, it says try out this program. Take your time to make sure you understand this program fully. It's doing something like this. Line equals dash, character equals W, line equals line plus char, equals dash plus W equals dash W. Print dash W. Now char equals O. Line equals line plus char. What is line? Well, we saw up here that line is dash W. So line is dash W plus O, and so dash WO, and we print dash WO. And now you should be seeing the pattern. We take what line had, we add char to it. So we get WOR, and so on. It says the details are important. What happens if you swap the last two lines and run this program instead? Name equals world, line equals dash. For char in name, let's print line, and line equals line plus char. It's clearly going to do something different. Let's think through it. This is like having code that says name equals dash WRLD, line equals dash, and now in the for loop we have char equals W, so char takes the value of the first character from within the string, and we print line, and then line equals line plus W. Now we go to char equal, so it's just going to print line, which is just dash. Then it's going to add the W on. So now char equals O. We print line. Well, what's line? It's what we had up here. In other words, dash O. And we do line equals line plus the O. Oops, I forgot my quotes here. That would be a problem. Let's run this and convince ourselves that this code is doing the same thing that all of this code is doing. Oh, it's asking me what do I think the result will be. Shoot. Let's take away all of this. Anyway, it's going to print dash, then dash W, and so on. Then dash WO, and so on. Let's run this without all my extra code. I don't know if I can change it. Okay. I guess I have to answer the quiz question as though I wrote the code the way they asked me to. So it's going to be just, the first one is going to be just dash. Here it is. Let's talk about why it's not this one. That's because we print line before we add char to it. So it can't be dash W on the first iteration. It also can't be dash WO on the first iteration for the same reason. But it can be dash on the first iteration and dash W on the second. So that one we can submit. Let's see. Okay, the details are important. It says, the last character in name only gets added to line at the end of the loop after print line has already run for the last time. The last oh, I see what they're saying. The last character in name, so the D only gets added to line at the end of the loop after the last print line has already run for the last time. So that character and the full name never get printed at the bottom of the triangle. If you're confused, try putting print line both before and after line equals line plus char. So let's go back to here, delete all this extra stuff, and let's print line here. And to make it even more obvious, let's also print before, and let's print after. And let's see what that does. Before we print dash, after we print dash W. Before we print dash W, after we print dash WO. Before we print before WO, after WOR, and so on until the end, which has before WORL. That's what we saw in the last version of the program. And after we have WORLD, but that wasn't getting printed because, to review, this is the code that we were dealing with. That gives us just whirl, which is a fun word in itself. Is it a word? I think it's WHORL. I'm getting a little distracted. I think it's time to take a break. I think you might want a break too after all this. Okay, let's see what this is. Let's get rid of those dash characters in the output. You might already be able to guess how. And then it introduces an empty string is a string containing no characters at all. Wow. It's written as just a pair of quotes surrounding nothing. Quote, quote. It's like the zero of strings. Adding it to another string just gives you the same string unchanged, in the same way that 0 plus 5 is just 5. Let's try that out. First, let's prove to ourselves that 0 plus 5 is 5. And, oh, try this in the shell. That's interesting. Quote, quote, plus quote, quote, plus quote, quote. Oh, I have to answer a quiz question again. So what are the options? We have an empty thing. And the way to think about this is, what if we took 0 plus 0 plus 0? We would just get a single 0. We wouldn't get 0, 0, 0. So that's the way to think about this one, is that we get a single empty string. We don't get these because there were no spaces to begin with. We don't get this because Python evaluates the pluses. It doesn't print them back to us. We also don't get this. I don't even know what that means, but that's not what we get. We don't get this with spaces, and we don't get the pluses, and we don't get an error. We simply get this first option, the empty string. Correct. Try this in the shell. Quote plus quote quote plus quote quote. It gives that. That's like saying 0 plus 0 plus 0. We can also do something like empty string plus quote 5, which just gives us 5, and we can do it in the other way around. 5 quote plus empty string also just gives you 5. It says don't confuse the empty string with quote space, which is a non-empty string containing one character, a space. So we look at that empty string and we look at that space string. They're different. Now fix the original program to get rid of those lines in the output so that for name equals world, it prints W, W-O, W-O-R, W-O-R-L, W-O-R-L-D. Okay. Let's do it wrong for starters. Let's say that line equals space and see that it gives us something slightly different. It looks the same, but we have a space here. Oh, also, our print is in the wrong position, so let's just fix that now. Line equals line plus char print line. What if we have an empty string at the beginning? There it goes. There's our triangle of world. It's a triangle world, or a world triangle. I don't know which. Oh well. Isn't that pretty? The pattern of starting with something empty and building it up with a for loop is very common. Yeah, I've seen this all over the place. And you're going to get lots of practice with it. Some initial empty values are empty string, 0, and bracket bracket, an empty list, which you'll see soon. You will see that soon. But before I click next, I'm going to take a little break. So thanks for watching, and let's get back to it soon. Okay, let's get back into it. Hello stream. Or should I say hello world? Either way works. The audio stream's current bitrate is lower than the recommended bitrate. We recommend that you use an audio stream bitrate of 128 kilobits per second. I bet that happened because I muted my microphone. Interesting. I guess the bitrate would be 0 if there's 0 information. I think that'll clear out now that I've unmuted my microphone. Okay, let's go to the next section. Building up strings exercises. Modify this program. Name equals named. Name equals quote WORLD. Line equals empty string for char in name. Line equals line plus char. Print line. The audio stream's bitrate 0 is lower than the recommended bitrate. That's weird. Why is it still saying that? Let me double check that the audio is working. Yeah, it's working. Okay. I guess it's just telling me about how it was before. I won't worry about it. Modify this program. So we're starting with, for char in line, line equals line plus char, print line, to add a space after every character in the triangles so the output looks like this. Now the interesting question here is, do we put a space before to put a space after every character? So we don't put a space before the character, but we do put it after the character. Do we put a space after the D? In this one we don't, which is actually kind of tricky. Let's run it just as it is first. And now, how can we add a space? Well, can we just do string concatenation and say plus empty string? Let's try this. We have world WWO. That's, okay. I'm going to nitpick here. They said it should look like this, but they didn't include a trailing space. But there is a trailing space here. I'm going to make a note to myself. I'm going to put a note in the chat here. Note to self, add trailing space to example here. Okay, I have that note, and it'll be associated with this time in the live stream, so when I go back and look at it, that'll be helpful for me. Tremendous. Now modify the program so that each line is backwards like this. Okay, let's go back to the original program and run it. We have WWO. How can we put it in reverse? You might be tempted to do something like reverse line, but one problem with that is we haven't learned how to reverse a string, and there are other problems with that, which is that I don't think it would work. But let's think about it this way. When we take empty string, let's think about it a different way. The first one's kind of unintuitive because you have to think about the empty string. But on the next one, what if instead of putting line in front of char, we put char in front of line? We're still appending it, but we're just putting it backwards. Let's try that. It says, brilliant. Code like line equals line plus char is so common that Python lets you... Oh, wait. That's moving on to a new topic, so let's talk a little bit more about what happened here. First, we had empty string, and char is W. W plus empty string is just W. But here's where it gets interesting. On the next time around, line was W. We take O plus W, puts O on the left side and gives us the reverse string as we build it up. Okay, on to new stuff. Code like line equals line plus char is so common that Python lets you abbreviate it. This means the same thing, line plus equal char. Note that there is no abbreviation for line equals char plus line. Oh, that's really interesting. I never thought about that. I mean, you'd be tempted. Okay, let's first prove that line plus equals char works. Yeah, but it's not reversed. You might be tempted to try to do equal plus, but it's going to give me a syntax error. Error trace back, type error, bad operand type for unary. Okay, I don't know what it's talking about there. Bad operand type for unary plus string. Oh, what if I did plus equals plus 5? Then it just takes it as plus 5 because it's similar to being minus 5, which is actually kind of going like this. And now I've gotten us way off track. So let's go back to the previously scheduled line plus equals char, and we get the world triangle. Now we're in a good place. Now use plus equals and a for loop to write your own program which prints the name underlined like this. There should be one dash for each character in name. This is interesting. The trick here is, okay, for each, we have a for loop. We're going to go do for character in name. You might be tempted to do print name and then print dash. Let's just see what that does. Uh-oh, it does. It starts to look good. We have world, but then we only have one dash, and then we have world again, and another dash. So we're back to the drawing board. One trick we can do here is recognize that we only want the name variable value to be printed once. So let's just do that in normal code outside of the for loop. Let's print name. And let's also print dash like we had before and see if this is any better. Okay, we've gotten closer. Now we have 5 dashes, but uh-oh, they're on new lines. Well, the solution here is to use the pattern we saw before and say line equals line plus the dash. Okay, that looks good. Now that we have that, we can print line, right? I've made a mistake. Do you see it? Oops, we have another triangle. So we calculate adding a dash on every time, but we also print it every time. How can we get out of the loop? Well, the way to do that in Python is to unindent. If we hit delete and take away the indentation, then this material is inside of the loop body, but this code is outside of the loop body and will only occur once. Let's show that that works. Okay, fantastic. I'm not going to talk about what they said there because I want to drive this point home in the following way. I want to print hello from inside loop body. Let's say inside the loop body, and then print hello from outside the loop body. Oops. So we have world, that printed up here. We have 5 times hello from inside the loop body. 1, 2, 3, 4, 5. And then we have the print line. And here we have hello from outside the loop body. Let's actually take away line and print name and make this really, really simple. We can even take away line because we're not using it. So hello from inside the loop body is going to happen 5 times. Hello from outside the loop body is going to happen 1 time. Let's run that. Hello from inside 5 times. hello from outside one time. Okay. It says, by the way, when you don't need to use a variable, it's common convention to name that variable underscore. For example, for underscore in name. That doesn't change how the program runs, but it's helpful to readers. This brings up a point that I made before. Computer code is to be read by computers and by humans, so it matters how it looks to humans. It says, let's make this fancier. Extend your program to draw a box around the name like this. Oh, this will be fun. Before we do that, let's just demonstrate. Can I copy this? Try to avoid copy pasting code. Oh, that's interesting. Okay. Name equals dash WRLD. Line equals quote. For underscore in name, let's just print name. Do a nice simple one. It prints world 5 times. It takes the char and puts it in the underscore, but it doesn't do anything with it. Okay, let's go back to this. Let's make this fancier. Extend your program to draw a box around the name like this. Let's see, what was the name? Let's get back to where we were. So print, we had print name, and for underscore in name, we had line equals line plus a dash, and then outside of the loop, remember we said hello from outside of the loop, print line. I think that's going to do it there. Yeah, world dash. Now, how can we fix this? We have to do a couple things differently. We need a plus. Okay, so that we can do with string concatenation. Quote plus line. That looks kind of funny with the plus in quotes and the plus out of quotes. In fact, I even made a mistake because I was turned around. So we have string plus the line, which is going to be the length of the line is going to be the same length as the name. I'll prove that as I go through it. So we have that, but now there's a problem. We printed name before we printed this first thing. Well, we can just delete that and say print name here, except that they want these pipes on either side. So let's do quote something plus name plus quote something. And what's the something? It's the pipe character on my keyboard over there. And now I normally would copy paste this line, but for the sake of practice, let's be typing. So print plus character plus line. Line is the thing that's been built up using dashes. And then plus the plus character. Now I went through that pretty quickly. So if you are watching this video after the fact, I invite you to push pause and try to memorize, don't try to memorize this code, but think about how this code worked and see if you can design it and write it yourself. I'd invite you to try that. Okay, let's run it. It says, you're getting good at this. Why, thank you, computer. Looks like you need more of a challenge. Maybe instead of putting a name in a box, the name should be the box. Whoa. Write a program that outputs this. This one's slightly tricky. I don't know if this is possible with a single for loop. And maybe they're trying to nudge you towards towards doing two for loops. I'm not sure if they are, but they might be. Let's pretend that I don't know what I'm doing and I am totally out of luck. And let's see where the hint drives us and see if we can step logically from the hint to the solution. Get a hint. You will need 2 separate for loops over name. Okay, I was right about that. So name equals WRLD. Actually, wait, can I go back? I want to just prove that this works with name equals Dan. Yep, that works. Okay, we'll do all that. So for char in name colon, and we're going to do it again for char in name. And let's think about why do we need two separate for loops over name. The reason is we're constructing two separate things. We're constructing WORLD on the vertical, and we're constructing space, 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 space on the horizontal. I can also say that we need to generate these spaces and have that ready to go before we start the loop that gives us the characters. Oops, let's go over here. So we'll start with name equals world. Let's say that line equals empty string. We'll follow that pattern. And now let's think about, we want to get something that has n spaces. So what we're doing is we're building up the line by adding a space every time. To do that, do we need the value in char? No, we don't, so we can use an empty string and say line equals line plus, or we can use the shorthand that we learned before and go line plus equals, and what are we adding? We're adding a plus. So now let's do a little test-driven development. Let's print bar plus line plus quote bar. Oops, bar. For char in name, I'll delete this for now. So we have name is world, line is empty string. For underscore in name, line plus equals a space. Now we should expect that with 5 characters in name, we should have 5 spaces between the bars. Let's see if that works. 1, 2, 3, 4, 5. And let's try it with Dan. Testing with different inputs. Okay, we now know how to generate the line that goes in the middle. So let's get to generating the first line. So that's going to be print the plus symbol plus just name plus the plus symbol again, and let's go plus name plus. This is going to look like name surrounded by pluses, name surrounded by pluses, and a line of spaces the same length as name surrounded by bars. So we're not at the final solution yet, but we're getting closer, right? Okay, it works for Dan. Let's see if it works for world. And let's see if it works for word. It works. Hooray. Now, we want this to happen how many times? N times, where n is the number of characters in word. So we have another for loop here for char in name, hitting tab to indent it by 4 spaces. Let's see that this gives us 5 of these. And if we have Dan, it should give us, oops, sorry about that. If we do Dan, then it gives us 3 of them, and they're 3 wide. Let's go back to world. Now the only thing we need to change is in place of these bars, what do we need? We need each character from word. So we can simply say char plus line plus char. Let's test that works. It says, sweet, you're really getting the hang of this. If you want, you can do one more optional bonus challenge below. We'll do that, but first I want to make a point of 2 different patterns that we're using here. We have a for loop where we, within the body of that for loop, over the n times, we calculate the value of line, and then we hold on to it. To make this more clear, let's put a new line there, and a new line here, and a new line here, and a new line here. All the new lines. Name equals world. What's the point I'm making? Oh yeah. In this one, we say that line plus equals space. So we're manipulating the value of line, and line gets printed later. In this one, in the body of this for loop, we're printing some things. So we're storing data, we're displaying data. It's two different ways of using a for loop. Okay, if you want to do just one more optional bonus challenge, I do want to do the bonus challenge. Thank you very much. If not, you can just continue to the next page now. You can come back and do this later if you want. Try writing a program that outputs the given name in a diagonal line. I.e. W. Oh, you know what? I'm going to say include trailing spaces in this example as well, maybe. Just add that. Okay, so we have W, we have space O, we have space R, we have space L, and oh, it indented it for me. Cute. 1, 2, 3, 4, 5. 1, 2, 3, 4 D. Okay. So we'll start it off in the same way. Name equals quote world. We use for char in name because we do want to access the character on each line. And let's say spaces. Let's have a variable named spaces, and that will keep track of how many spaces we want on each line. And let's print spaces plus char. Now let's run this. There's an error. Maybe you can see it. But let's just say that we had kind of thought maybe this is the right direction. Let's start writing the code and let's just run it and see what happens. It says name error, spaces is not defined. And then we say, oh right, I have to have a value for spaces. Excuse me. So for that, let's start with empty space. It's getting kind of dark. I should turn on a light. Although it seems like I'm showing up all right on the camera, so that's good. Spaces equals that. Let's run it now, and we have world, but we don't have the spaces that we want. So let's say that spaces plus equals, let's add a space on each iteration of the for loop. Will this do the job for us? Not quite. Let's see why. Oops, we ended up adding a space before W. They didn't want a space before W. They only wanted a space before O. So let's just move the print statement. You know what? I don't need to type it again this time. We print spaces plus char. The first time around, that'll be empty string plus char, so W. And then we add a space on each iteration, and we should effectively see this thing move one character to the left, and it should work. It says, wow, nothing can stop you. That's right, nothing can stop me. Ha. Okay. Basic terminology. This looks like it could be potentially boring, but let's go with it anyway. Here's some words you need to know. An expression is a piece of code that has a value. For example, in this line of code, sentence equals hello plus name. There are 3 expressions. Hello space, that's an expression. Name, that's an expression. And hello plus name, that's an expression. Each one of those has a value. And we can see that by going in the shell, HELLO space, that evaluates to a value. Name is going to be that's interesting. Name still has something from here. Let's run this so that now name still has a value. That's really interesting. Let's say name equals Bob. Then we don't have hidden state. Okay. Now we can say hello space quote plus name. And it does hello Bob. The point we're making here, let's go back. Hello space is an expression, and it shows an output in the shell. Name is an expression, and it shows an output in the shell. Hello plus name is also an expression, and it produces a value in the shell. So that's the pattern here. By contrast, the full line sentence equals such and such, sentence equals quote hello quote plus name, does not produce an output in the shell. Okay, by contrast, the full line sentence equals dot 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 is a statement. We have expression and we have statement. It's a command that tells the computer to perform an action. It has no value of its own. This means, for example, that you can't add statements together. This code is invalid. Parentheses word equals quote hello. Let's do this in the shell. Word equals quote hello quote plus paren name equals quote Bob end quote hello. Let's see what happens when we try to run this. Syntax error, invalid syntax. Maybe you meant double equals. We're not going to talk about double equals right now. Specifically, a statement like sentence equals blah blah blah. A program is a list of statements which are executed in order. A for loop is a compound statement, meaning that it has a body of its own which contains other statements. Most statements will also contain expressions, and expressions can contain other smaller expressions, but expressions cannot contain statements. That was a lot of information, so I'm going to be kind of going through examples to show that, but let's move on for now. The process of calculating the value of an expression is called evaluation. Note how it contains the word value. The computer evaluates 1 plus 2 to get the value 3. Let's show an example of that. 1 plus 2, we get 3. The process of executing a loop is called iteration. That's onto a new concept, so let's back up. A program is a list of statements which are executed in order. So we could say like sentence equals hello quote plus name, and we could print name. That's a simple program. Oops, name is not defined. Huh. Name equals world. Print name. Nam. Okay, world. We got there. Name equals world. That's a statement. Sentence equals hello plus name. That's a statement. Print name, I assume that's a statement. A command that tells a computer to perform an action. Yeah, that's print is telling it to print something, so that sounds like a statement to me. But let's go on. Assignment, the value is assigned to the variable. A program is a list of statements which are executed in order. I've said that. Evaluation, we did that. Okay. Wait, a for loop is a compound statement, meaning it has a body of its own which contains other statements. So let's look at an example of that. Name equals world. For char in name, print, let's print name, and let's print char. Run that. We go through the things. Most statements will also contain expressions. So we could talk about like name plus exclamation point. And in this case, name plus exclamation point is world exclamation point. It's an expression that can be evaluated to a value. Most statements will also contain expressions, and expressions can contain other expressions. So let's see an example of an expression containing an expression. Name is an expression, exclamation point is an expression, and name plus exclamation point is itself an expression that contains two smaller expressions. But name equals world is a statement, and if we say thingy space plus name equals world, we're going to have a problem. Syntax error. Remember, syntax error is when Python can't understand the code that you put in because there's something wrong with your code. Okay, now back to looping. The process of executing a loop is called iteration. Code like for char in hello is iterating over the string hello. The fact that it's possible means that strings are iterable. By contrast, numbers are not iterable, which is exactly what Python will tell you if you try for char in 3. Let's try that. Char in 3, print char, and we're going to get some kind of error. Oops. Error traceback for char in 3, type int object is not iterable. Interestingly, if we do quote 3, what will happen? We will see 3. So it is iterable even though there's only one character. If we do 33, we'll see 3 and 3. Here's something controversial. What if we try to iterate over an empty string? It is iterable, but nothing happens. Even if we try to say print 5 here, so it's iterable, but there's nothing to iterate over. So none of this code in here executes. That's kind of interesting. Okay, each run through the loop is called one iteration. So in this example, there will be 5 iterations. Okay, so that's like for char in hello, hello, colon. It's iterating over the string. We'll print char, hello. Okay, that's enough for that section. We're about to ready to go on to next. However, someone is blowing up my phone, so I'm going to check on that. Okay, let's continue on. Sorry about that. Introducing if statements. Control flow. Oh darn it, my phone is turned on. Why is my phone making noise? Now we're going to learn how to tell the computer to make decisions and only run code under certain conditions. For this, we will need to look at a new type of value. You've seen numbers and strings. Now meet Booleans. There are only 2 Boolean values, true and false. Try this program. Condition equals true, print condition, and condition equals false, print condition. Notice that we didn't say quote true. What if we did that? Well, it looks the same, but it means something different. So let's not go down that path, and let's just stick with condition equals true and condition equals false. Booleans are meant to be used inside of if statements, sometimes also called conditionals. Here's a simple example for you to run. Let's say if true, print this gets printed, and let's say if false, print this does not. Notice that we have this gets printed, this does not, and it's not to be found. Makes sense, right? Note how the code inside the first if statement ran, but not the second. In general, an if statement looks like this. If condition, body, with a colon, where condition is any expression which evaluates to a Boolean. Now let's just take a second and talk about expressions evaluating to a Boolean. If we say true, that is an expression that evaluates to a Boolean. If we say false, that is an expression that evaluates to a Boolean. there are two Boolean values, true and false, and in Python they're shown by just TRUE with a capital T and FALSE with a capital false. This allows for something slightly, I guess, unfortunate, which is you can do silly things like true equals false. Print true. It gives us false. Here, true is a variable name, lowercase t, and false is the Boolean value false. It kind of hurts my brain to see that, so let's run this and make it go away. Which evaluates to a Boolean. 5 is an expression, but it does not evaluate to a Boolean. There are other things where we can take expressions, more complex expressions, that do evaluate to a Boolean, but we're not going to show examples of those right now. Okay, body, that's condition. Now, body is an indented list of one or more statements. The structure is quite similar to a for loop. Note the colon, which is essential. When the computer sees if condition, it checks if condition is true. If it is, it runs the body. If not, it skips it and continues to the rest of the program. Let's print the rest of the program. So you can see even though this does not, the rest of the program does. Here's a more interesting example for you to run. We have sentence equals, quote, hello world. Excited equals true. If excited, colon, sentence plus equals exclamation point, and we print sentence. Will it be hello world or will it be hello world exclamation point? Well, we have true here. If true means that this will execute, and we give the computer the instruction to add the exclamation point to sentence, then when we print sentence, we should expect to see hello world exclamation point. It says that's correct. Remember that sentence plus equals exclamation point means sentence equals sentence plus exclamation point. Change excited equals true to excited equals false and run the program again to see what the difference is. We'll do false and run this. What do you think the result will be? Well, again, similar to before, we consider the Boolean value in place of excited, which is false. So this code won't execute. But this code will, so we'll have the original value of hello world, which is going to look like this. Submit. Okay, time for an exercise. Modify the program above to include the extra Boolean parameter confused. So the program should start like this. Sentence equals hello world, excited equals false, confused equals true. Sentence can be any string and the two Booleans can be either true or false. When confused is true, the printed sentence should have a question mark added to the end. If both confused and excited are true, the sentence should end with exclamation point, question mark. I was wondering if they could both be true. So it starts with sentence equals hello world. We have excited equals true. Excited equals false, sure. Confused equals true. Now, if excited, we add the exclamation point. That's already there. Let's use another if statement to go with if confused, sentence plus equals question mark. Print sentence. Now let's test it with confused. And this says, well done. This program can do 4 different things depending on how you combine excited and confused. Try them out if you want. Let's try them out. Let's try them both false. We have just hello world. Let's try only excited. Hello world exclamation point. Let's try only confused. And we have the question mark. Now let's try both. We have exclamation point question mark. But let's assume that you're not confused, because I hope you're not confused. And let's just do the excited one. Try them out if you want. Okay, we have tried them. Let's continue on. combining compound statements. Compound statements, like for loops and if statements, have bodies which are a list of inner statements. Those inner statements can be anything, including other compound statements. So, for example, we could have if true, then we could do another if true, print very true. So how do we think about this? If true checks the value of the Boolean, it's true, so we go through and we evaluate this code. If true checks the value of the Boolean, and it is true, so we evaluate this code. And when we evaluate this, when we execute this, we print very true. Okay. It's going on. Those inner statements can be anything, including other compound statements. Try this example of a for loop inside an if statement for when you want to show you're really excited. We have sentence equals quote hello world, excited equals true, if excited colon new sentence equals empty string, for char in sentence. What are we doing? For char in sentence, new sentence plus equals char plus exclamation point. Okay, I see what we're doing. Sentence equals new sentence. Let's try that and talk about why it did. Oh, lots of choices. Also, it's interesting that we had to use new sentence. That turns out to be important. But, okay, let's step through this code. If excited is true, so yes, all of this executes. Now we're looking at for loops again, so this is kind of review. New sentence is empty string. We're starting with an empty string, and then we're going to build it up. For char in sentence, the new sentence plus equals, so the new sentence equals sentence plus char, which is going to be H and E and so on, plus exclamation point. Then we take the new sentence, we store it into sentence, and print sentence. So we're going to have H exclamation point, E exclamation point, and so on. Let's talk about where we're not going to have hello world. Well, excited is true, so we're going to be changing things. We're not going to have a bunch of exclamation points because that would be ignoring the char there. We're not going to have the string followed by all the exclamation points because that ignores the fact that these are interlaced. That's the opposite, and that's also not correct. This one's not correct because that's only a single exclamation point. Same problem here. That's a nice one, but that's also not correct. Here we have H exclamation point, E exclamation point, and so on. That's, oh, and the space also gets followed by an exclamation point because space is a character, so yeah, that makes sense. So that's our answer. Really excited, yeah. Okay, it's been 2 hours, so pretty soon I'm going to take another break. It says, note how the body of the if statement, 4 lines, is indented as usual, while the body of the for loop 1 line is indented by an additional 4 spaces in each line to show that those lines are within the for loop. You can see the overall structure of the program just by looking at the indentation. Alternatively, you can put an if inside of a for. Hey, it lets me copy this one, but let's actually type it. Well, sentence equals hello world, that's the same. Excited equals true. Let's have new sentence equals empty string. For char in sentence, new sentence plus equals char. If excited, new sentence plus equals exclamation point. Sentence equals new sentence. Print sentence. Let's run that. Oops. Interestingly, it's the same result. These two programs have the exact same result. However, the first one is more efficient as it only iterates over the string if it needs to, since when excited equals false, nothing changes. That's kind of interesting. Let's look at why that's true. Oops, pardon my mic bump. Where was I? Oh yeah. If excited is false, none of this happens. Whereas in this case, regardless of whether excited is true or false, all of this has to happen, and then this excited check has to happen a bunch of times. So yeah, less efficient. Let's go to next. Understanding programs with Snoop. That's a new thing to me. Run this program. We'll copy it. Oh, it even puts it there for you. That's nice. Run this program. What do you think the result will be? Okay, sentence equals hello world. Include equals false. New sentence equals empty string. For char in sentence, if include... Oh, this is interesting. New sentence plus equals char. And now include equals true. Print new sentence. I say it's going to be hello world. And the reason I say that is include will be false at the beginning, so this first char is h. We don't include h, but subsequently include will be true, so we do include e, l, lo, and world, so on to the end. So that's what the answer will be. Programs are starting to get complicated. It's time to introduce a new tool to help you understand programs. Click the Snoop button to run the same program while also showing what's happening. We have a new tool. It's called Snoop. I have not seen this before. I think this is special and individual to this learning platform. So that's kind of cool. Snoop. Ta-da! Scroll to the top. It's a lot of information. Top of the terminal, and let's walk through what Snoop is showing you. It starts out very straightforward. 1. Sentence equals hello world. 3. Include equals false. 4. New sentence equals empty string. 5. For char in sentence, now we have ... char equals h. The first lines are simply showing you the lines of the program that the compiler ran. On the left is the line number as seen in the editor. Running for char in sentence assigns a value to the variable char, so Snoop shows you that value. Okay. Oops. Oh, why is it... I won't try to select things because that seems to be throwing off the scroll. Char equals h. Line starting with a ... indicate a new variable or a change in the value of an existing variable. Such lines will not be shown when they're redundant, which is why Snoop output doesn't look like this. Sentence equals hello world, ... sentence equals hello world. Include equals false, ... include equals false, blah, blah, blah. The next two lines are if include equal true, what's important here is what's not showing, because include is false. Okay, this is... I moved a little too quickly for that, and it actually kind of slipped past me what was going on. What's important here is what's not showing. Because include is false, line 7, new sentence plus char. See, we skip from 6 to 8. Line 7, new sentence plus char gets skipped. But then include is set to true, so that next iteration of the loop, sorry, is different. We go back to 5 for char in sentence with char equals h. Then we have if include and 8. Oh wait, h. We're on to e. Sorry. If include, now include was true because we saw that up here. New sentence plus equals char. And there we get new sentence equals e. New sentence plus equals char runs for the first time, and the variable new sentence gets a new value. Now modify the program to the opposite. Only print the first character, leave out the rest. Well, before we do that, let's review what Snoop is telling us. Sentence equals hello world. Include equals false. New sentence equals empty string. For char in sentence, now it tells us that char is h. If include, it executed that line, but it didn't execute the body of the conditional because include was false. Now include equals true. And it doesn't tell us ... include true equals true because we already know that include equals true. But we go back to for char in sentence, char equals e. It's telling us the new value of char in this iteration of the loop. It tells 6 happens if include, and then it tells us that 7 happens, new sentence plus equals char. And then it tells us that new sentence is e, and I think that's because we need that because it isn't immediately apparent from line 7 what the value of new sentence will end up being. To answer that, you have to look back to line 4, which defined new sentence, and you'd have to look at char where that was defined. So it's a good thing that it's telling us new sentence equals e. Okay, back to 8, include equals true. Not much to say about that one. We're just storing include equals true to include again. Now we're back to for char in sentence with char equals L. If include, that's yes, that's true. So we say new sentence plus equals char and get new sentence is L. And what about the next time we go through all this of the same thing? We're going to have ELL. See the pattern emerging? Char is O and we have ELLO. And let's go on to the last one. Char is D and we have ELLOWORLD. We set include to true one more time, which is redundant, but oh well. And for char in sentence, print new sentence. Wait, why is it saying 5? I guess it's I guess here it's just letting you know that that was the last time that we went through the for loop. It's like this is exiting the for loop. Let me test if that's true. Sentence equals hi for char in sentence print char. Let's just see what Snoop does with this. Sentence equals hi for char in sentence. Char equals h. Pardon me. Char equals h. Print char, and it's h. For char in sentence, char equals I. Print char I. For char in sentence, and that's us exiting the loop. Okay, that's just how Snoop does it. Let's go back to this. Back, Snoop, and we print new sentence, hello world. Okay. Now modify the program to do the opposite. Only print the first character, leave the rest out. So we're totally changing what the program is doing, but we actually don't have to make very many changes to the program. We don't have to change the structure of the program because the structure of the program is such that it does one thing with the first character and something else with all the other characters. So all we have to do is change true to false, or change false to true and true to false. True is false and false is true. And this should only run, let's just run it. It says, great job, you're working with increasingly complex programs. Very good. Let's snoop this. What's interesting is we have not a very much output from the final output of the program, but in Snoop you see that there's all this stuff. We have all these cases of if include. Well, the first case is H, and include is true, so we add char to new sentence and we get H. But in every other case, when we try if include, we don't execute the body of the conditional. So sentence stays the same, or new sentence stays the same, and we print new sentence. Okay, it says, great job, you're working with increasingly complex programs. I have been on this stream for 2 hours, so it's time to take a break. But out of curiosity, I want to see the table of contents and see how much further this goes. Okay, we have a tic-tac-toe project, we have dictionaries, we have Boolean operators, we have functions, we have nested loops, and here we are, there's lists, and we're in if statements. So we're like, it says we're almost halfway through, although I think that it may move on, it may move a little more slowly as we get onto more parts of it. But anyway, let's go back to Snoop. It says, great job, you're working with increasingly complex programs. I'm going to print great job, And that's addressed to any of you who may be following along with this video. Great job on paying attention and learning something new today. Okay, let's go back to OBS, and maybe I won't mute the mic this time. No, I'll mute the mic. So we turn off the webcam, and we turn on the Be Right Back. And we mute Okay, we're back. I'm going to look at the table of contents and decide how much further, if any, I'm going to go into this project today. We're on understanding if and else, the equality operator, introducing elif, other comparison operators. I think I'm actually finished for today. So sorry if you hung around and now found that there's nothing more to watch. Oh well, these things happen. Okay, I'm going to close down the stream and just say thank you for watching.